Well, hello, and we're back again for number 3. Session number 3 on the free CCNA CyberOps this time. We're going to be looking at Chapter 2, Windows Operating System. Wow, it seems only like 20 minutes ago we were looking at the CCNA 2. Okay, if anybody's stuck with me for the entire evening, then you'll have done IT Essentials, you'll have done CCNA 2, and now CCNA CyberOps. Oh dear, my head's spinning. Hi everybody, people are streaming in now. I'd give them a few seconds more just to get a few more online. Okay, so yeah, now we're moving into Chapter 2, which is a basic look at the Windows operating system. It doesn't go particularly deep. Chapter 3, Linux, which follows, is probably going to be a little bit more unusual for most people. I think a lot of people have got a reasonable understanding of the Windows operating system, at least at a fundamental level. When it comes to the Linux operating system, it's surprising how many people go, yeah, right. Yeah, I've heard of Linux, but haven't used it that much. Well, if you're going to get into security of any sort, you need to know all of the operating systems, and especially Linux. Okay, but tonight is not Linux, tonight is Windows, and it is now gone 8 o'clock, so I think we'd better make a little bit of a start. I'm going to go a little bit experimental at some point while we're doing this. I always like to do that, and I'll try to show you something a little bit unusual, revolving around an older version of Windows, Windows 7. This particular little trick can't be used with Windows 10, but there's a nice little trick that we can use with Windows 7, by which we should be able to find the passwords of the users on the system. So that might be a nice little bit of security auditing, I suppose is one way of putting it. Yeah, now, with this chapter in particular, but with all of the chapters, there's so much in the chapters, and there are lots and lots and lots of labs. So you can click on the lab link and it will open up a Windows document, and that Windows document will lead you step by step through labs, giving you an example of what you need to do, what sort of output it should be. I can't really easily replicate all of that in an hour session. So what I'm going to do is, like I say, there's no point in me trying to replicate every single little detail, including the labs that you've got in Chapter 2 or any of the other chapters, in an hour session. So what I try to do is I try to go over some of the high points, leave you to do the labs, and it's very important that you do the labs. There's an awful lot to learn by doing the labs that you can click on and open up a Word document and give you all that information that's required. So I recommend that you read the chapters in depth, you do the labs before you take the end of chapter test. It really is very worthwhile to do those labs. It's amazing how much more you understand the theory when you can actually do a lab and look at the practical. And like I say, there's no way in a million years, even if I tried to, I just couldn't fit in everything that's in those chapters, including the practical labs, in an hour session. So what we're going to do is we're going to hit some of the higher points, and I'm going to do a few other little things that don't appear in those labs. So we're going to be looking at the Windows operating system. Now, Windows has quite a long history. It goes way back to 1985, just a little bit before 1985, so it's been out for a very, very long time. The first computers, they didn't have the sort of modern storage devices that we think of these days, things like hard disk drives, optical drives, flash storage. So the first storage methods that were used on some of those old mechanical computers and early electronic computers were punch cards and paper tape, and later on magnetic tape, and even audio cassettes. I can actually remember when I was very, very young. I was probably about 13 or 14 years old, and my dad and mum bought me a ZX81, a Sinclair ZX81. That was my first ever computer, and you used to store the programs for it on a audio cassette, just a standard audio cassette, and it had a 16K RAM pack, if I remember correctly. 16K, it's hard to believe these days. But yeah, floppy disk drives and hard disk storage, this requires software in order to correctly read from and write to and manage the data that's stored on those storage devices. So a disk operating system, or DOS, is the operating system that the computer would use to enable those storage devices to be able to read and write files effectively. So there are many types of disk operating system. IBM come up with what was known as PC-DOS, and Microsoft bought that out and developed it into what's known as MS-DOS, or Microsoft DOS. And in this case you would have used a command line interface, so as people could create programs that manipulate data files and things like that. So it was done through the DOS prompt. We can see on the screen there MS-DOS is running, and you would actually type in the commands. I can actually remember vaguely when I was a child doing these sort of things. The DOS system was actually underlying many of the later versions of Windows, so even when Windows had a graphical user interface, it ran over the top of the MS-DOS, the Microsoft DOS operating system. So with the very first version of Windows being Windows 1.0 way back in 1985, that was the year after I left high school, the disk operating system still effectively controlled the computer and its hardware. It's on later Windows operating systems, DOS was dropped and they were built upon Windows NT, or Windows New Technology, much more powerful than the disk operating system. Okay, but nevertheless, you still have a command prompt, and in modern versions of Windows you've got what's known as PowerShell, which is much more powerful than the command prompt. And at the command prompts and at PowerShell you can type various commands: cd, dir, change directories, list the contents of directories, del to delete files, and things like that. From a historical point of view, so back since 1993 there has actually been more than 20 releases of Windows based on the NT, or New Technologies operating system. And from Windows XP onwards we actually progressed onto the 64-bit editions, so we actually had 64-bit processors. The great thing with a 64-bit operating system is it can theoretically address 16.8 million terabytes of RAM. It's hard to get your head around that, isn't it? 16.8 million terabytes of RAM with a 64-bit operating system. Actually, I wonder whether we can calculate that out. It's worth giving it a try, isn't it? So binary 2 raised to the power of 64. So let's give this a little try, see what it says. 2 to the 64 equals, that's a big number. Now we need to get that into terabytes, so that's in bits. So in order to get that into terabits we would need to divide by 1024, that will get us into kilobits, and then divide that by 1024, which will get us into megabits, and then divide that by 1024, which will get us into terabits. Okay, that's not quite 100% there, is it? Actually, hold on a second. Do one more division. There we go. Let's see, bits, kilobits, megabits, terabits. Now that is 16.8 million. Not sure where I've got out slightly. I seem to be out by a factor of a kilobit there, but you can see the 1677216, which is as near as, damn it, the 16.8 million terabytes of RAM. Each subsequent release of Windows, the operating system has become more refined, so we've got so many more features. Some of the features you like, some of the features you don't like. However, overall it's become a much more refined operating system. We can see in this particular slide Windows 7. I used to love Windows 7. Windows 7 was a superb operating system. I kind of missed that actually. Some of the Windows operating systems, like Vista, were well, you could say good things and bad things about Vista. They seem to go in a kind of up and down spiral with Windows operating systems. You get a good one, and then you get one that wasn't quite so good, and then the next one came out was brilliant, and then the next one wasn't quite so good. So obviously, with our newer versions of Windows, we have a graphical user interface, so it helps the users work with data files and software much more effectively. Like I say, this is very basic stuff, so we can go through this very quickly. I'm sure everybody understands that the GUI is a desktop and it's got a taskbar, start menu, search, etc. Right-clicking an icon can bring up additional functions, so this is known as the context menu. We've got the Windows File Explorer, which is a tool used to navigate the entire file system of the computer. Okay. By the way, I posted on the Open University Cisco Academy Support Center website in Facebook a supplementary video. That supplementary video was how you can get hold of the evaluation copies of Windows 10, it's Windows 10 Enterprise, and Windows Server 2016. You can get a 90-day evaluation version of Windows 10 and a 180-day evaluation version of Windows 2016. Also, how to install them in Oracle VirtualBox. So should you not know where to get that evaluation software, these are full-blown Windows operating systems, it's just they'll only run for 90 and 180 days respectively. Or if you've never actually installed one of those on Oracle VirtualBox and you just want to have a little look at somebody doing it, I've got that video on the OUASC Facebook website. I hope that might be useful to you. I've got plenty of Windows operating systems installed in VirtualBox, which we'll be having a look at in a moment. In fact, in a moment I'm going to hopefully show you how on a Windows 7 machine, we can't use Windows 10 because Windows 10 has actually fixed this vulnerability, but on a Windows 7 machine I'm hopefully going to show you in a moment how we can basically obtain the passwords of the users on that system. Okay. Operating system vulnerabilities. So, as we know, operating systems consist of millions upon millions upon millions of lines of code. The installed software, the applications and things that exist on top of the operating systems, they also contain millions and millions of lines of code. It's not humanly possible to write all of that code and get it absolutely perfect with no vulnerabilities every single time. So in amongst that code there will be vulnerabilities, and all a vulnerability is it's a flaw or weakness, and this can be exploited by an attacker. Okay, to take advantage of a Windows or any other operating system vulnerability, the attacker must use a technique or a tool that exploits that vulnerability, and then they can go further by using the vulnerability to get the computer to act in some malicious way that it's not actually supposed to work that way. Typical common vulnerabilities for the operating system are viruses and malware, malware being malicious software. Of course, by default, Windows has the Windows Defender. The Windows Defender gives a reasonable level of protection, so there's a suite of protection tools built into the system. If you switch Defender off, it will become more vulnerable, of course. However, I wouldn't rely purely on Windows Defender. I would try to get hold of some good third-party antivirus, anti-malware software. Again, unknown or unmanaged services. So there are many services that sort of run behind the scenes on the operating system, and it's important to make sure that all of these services that are running are identifiable and safe. You know what that service is. There's not some unknown service running in the background. This could be some backdoor into your Windows operating system. It could be a keylogger logging all of the keystrokes on the keyboard. Another thing we need to do is we need to make sure that we use encryption. Encryption is a wonderful thing because it gives us confidentiality. Confidentiality is made by the use of strong encryption. So when data is not encrypted, it can be easily gathered and exploited. This is not just encrypted upon the file system, but also encrypted in transit from one system to another across a network. So you want to use some strong level of encryption. For instance, the Advanced Encryption Standard, AES. You can use BitLocker in order to completely lock down the information on your hard drive. We also need to implement a good security policy, particularly important in an enterprise. There are many settings in the Windows Security Policy Control which we can look at which would prevent attacks. We also need to think about the firewall. So by default, Windows has a firewall built in, and that firewall is used to limit communications with devices on the network. Over a period of time, you may find that certain rules no longer apply. So you may have had a port that was left open for a specific connection to a certain type of application. If the application is no longer in use, you need to make absolutely certain that you review your firewall settings and ensure that any rules that are still applicable you keep, and any rules that are no longer applicable you remove. File and share permissions. So these permissions should always be set correctly. It's very, very easy in Windows, if you're not careful, to just give the everyone group full control, but that would just allow all people to do basically whatever they want to do with those files. So it's best to provide each user or group with the absolute minimum level of permissions they require for their files and folders. Always try to make use of strong passwords, nice complex passwords, uppercase, lowercase, numbers, special characters. People who choose weak passwords or do not implement passwords at all are just leaving the system and their organization open to exploitation. In particular, the administrator's account, or if you're using a Linux machine, the root user account needs to have a very strong password. You should also log in as the administrator or on a Linux machine root only when necessary. Moving back to passwords, let's have a little bit of fun. Let's see if we can do something here with Windows. What I'm going to do is I'm going to see if we can break some passwords on a Windows machine. Okay, so what we've got is we've got Oracle VirtualBox, and initially I actually tried to do this on a Windows 10 machine, but I couldn't find a version of the software that I was using that would actually break the passwords on a Windows 10 machine. Given time, it may be possible to do so, but I did manage to find on an old external hard drive earlier this morning a VirtualBox virtual machine image for a Windows 7 machine I used to use maybe 2 or 3 years ago. So I thought, oh, what the hell, I'll export it into Oracle VirtualBox and we'll fire it up and we'll use that. So I do have a Windows machine now, and what we'll do is we'll fire it up and we'll just create some passwords. We won't create really hard passwords, we'll just create relatively simple passwords, because if we create really hard passwords, because it's running in a virtual environment with a limited amount of processor cycles and RAM, it would take too long to show you what's happening. So what I've got is I've got a Windows 7 machine. We'll start that up. Okay, so Windows is now starting. I've got to be a bit careful here. I've just noticed I've got 2 screens here. Yeah, there's the other one. That's one of the nice things with Oracle VirtualBox. You can actually set it up so you have multiple screens, which is kind of nice. I'll get rid of that second screen. I'll log in as Kevin. I've already got a user called Bob on here when I was testing things earlier on. Bob's got a password of November. I'll log in as the user Kevin, who has no password. You can see I'm a bit of a Star Wars fan. This was some time ago, and this was obviously what my desktop wallpaper was back in those times. Okay, you'll notice I've also got VirtualBox Guest Editions installed, because when I dragged the window to a different geometry, it automatically resized. Okay, so there's my Star Destroyer. Let's see if we can do this. I'm going to go into the control panel. I do hope this works. We're flying by the seat of our pants here, ladies and gentlemen. We'll go into our control panel and we'll go to user accounts. numerous ways of doing this. Manage another account. Let's see what we can do. Let's create a new account. So we've got Bob, who's a standard user. He has a password of November. What I'd like to do is, could somebody type in the comments bar a password of some sort, but nothing too complicated, because like I say, we don't want this to take too long. But just so as it's not something I've typed in, could somebody type in the comments bar a very, well, reasonably poor password, just something that we hopefully can get the cracking software to guess relatively quickly. Okay, so while somebody's thinking up a password, what I will do is I'll create a user with the name of Emma. Okay, and then we create that account. We'll click on Emma and we'll create a password. Windows 7 VB. Yeah, to be fair, it'll probably do that. We'll give it a try. I'm not sure I typed that correctly. Let's do that again. Windows 7 VB. Windows 7 VB. Okay, and then we'll create the password. So this is just a Windows 7 virtual machine. We'll create another user as well. Do a few. So if anybody else wants to jump in with a few passwords, that'll be good. We'll have a user called Joe. Create account. Joe's a standard user. Let's have a little look. Football. Yeah, we'll do football. We don't want anything, like I say, too complex. Just because of time, that's all. So, football. FOOTBALL. Well, now we got the World Cup rugby on. We probably should have had rugby, but still. That's that one done. Anders. Yeah, we'll do Anders' password on here. So, well, it's not Anders' password, I'm sure. Anders wouldn't have a password like this. My good friend in Sweden, he says, awesome. So we'll do one more. Create new account. We'll have the user Anders with a password of awesome. Now, like I say, you can't do this in Windows 10 because Windows 10 has fixed this. Awesome. Okay. Create password. I think that's probably done it. Let's just manage another account. Let's see. So we've got 1, 2, 3, 4. We've got 4 users who've got passwords. I don't have a password, which is a bit naughty for the administrator. But and then the guest account is switched off. So we've got 4 passwords to guess. Okay, this is good. So we'll close that and we'll shut the system down. And I hope it doesn't do any Windows updates. It probably won't actually, because Windows 7 is very much end of line. Okay, that's powered down. And what we're going to do is we're going to make use of a piece of software. Let me open up a browser window. Let's bring a browser window across. The piece of software we're going to use is known as OPHCrack. OPHCrack. Okay, OPHCrack. And what we're actually looking for is we're looking for the live CD. Let's see if I can get to it a bit quicker by typing live CD. Download the OPHCrack live CD. No installation required. So what we'll do is we'll download the OPHCrack CD for Vista and 7. Notice there is not one for Windows 10. We do have an MD5 sum on here, so we can do a quick check to make sure that the download has come across okay. I'll right click on that, copy it, and I'll open up like I say, I'm on a Linux machine at the moment, so what I'll do is, I haven't got Notepad, but I've got something similar. I'll open up Mousepad, we'll paste that MD5 sum in here, and what I would then do is I would then download this piece of software. I've already downloaded it, you'll probably have guessed. So it says your download will start in 3, 2, 1, go. I'm hoping that's going to tell me where I've put it. There we go. So my downloads folder, CCNA CyberOps, you will notice that I've already downloaded the live CD. It's an ISO image, so we can point VirtualBox directly at it. It's not a very big one. Let me tell you first of all what is actually going to go on now. On a Windows computer, the passwords are stored as hashes, and they're stored as hashes in a SAM or Security Accounts Manager file, which is in Windows System32 config. However, that file is locked while Windows is running. So while Windows is running, you cannot even access the file, let alone anything else. So what we do is we start up, or in other words boot the system on a Linux live CD. This way Windows is not running, which means that we can mount the hard drive, make the hard drive read and writable. We can go off and navigate to that Windows System32 config directory, find this Security Accounts Manager database file, pull the hashes out, and then what Offcrack will do is it will use pre-computed rainbow tables. And a rainbow table is basically pre-computed crunching of the algorithms. It basically knows the algorithm that's in use, and it tries an entire database of various words and brute force in some cases, depending on how big the table is, plain text, runs it through the algorithm and looks at the hash. If that hash matches one of the hashes in the Security Accounts Manager file on your Windows machine, then it means that the plain text they passed through it was your password. Now that's incredibly processor intensive. So what the rainbow table is it's a pre-computed list of those hashes in a database format. It's been pre-computed on a supercomputer, so all it needs to do is it just does a quick database lookup. As soon as it finds the hash that matches, then the plain text that was put through the algorithm is your password. So I have the MD5 sum, and what I would wish to do is I'm going to open up the file manager, and I will navigate to it was in downloads, wasn't it? Downloads, CCNA CyberOps, Linux, OPHCrack. Okay, so there's my download straight from that website, OPHCrack. What I will do is I'll right click in that folder to bring up a terminal window. So even on a Windows chapter we're doing some Linux. You knew that would happen. And then I'll do an MD5 sum. It's actually built into the operating system on Linux. We don't need to install any software or anything. I'll just do an MD5 sum directly from there on OPHCrack ISO. It's very, very fast. And I can check to see if this hash matches the hash in the notepad file. We should be certain that we've got a good, not corrupted download, and those two hashes are absolutely identical. I would recommend you to always make sure that you check the hashes of any downloads that you need to use that are important, especially like operating systems or critical application software. You should always make sure that you check the MD5 or the SHA-1 hash to make sure that it hasn't been corrupted in the download process. Okay, so I will now get rid of that window. I'll get rid of the terminal window. I can actually close the file window, and this is the virtual machine, the Windows virtual machine we were looking at. What I'm going to do now is I'm going to go to storage, and I'm going to point the CD-ROM, the VirtualBox CD-ROM, at that OPHCrack disk. So effectively, it's the same as if this was on a real system, me having OPH crack on a thumb drive or on a CD and booting the Windows machine off of it. This is a good demonstration to show students, and it's not too dangerous because, like I say, this doesn't work on the latest versions of Windows, but on older versions it will. Okay, so the virtual machine now has OPH crack on the CD, which is the first boot device. So now when I power it up, it should start up OPH crack. And there we go. And this of course is another reason why you should never ever allow your computer BIOS to be got into, because if people can get into your computer BIOS or UEFI, they can change the boot order, and they can boot to external devices like CD-ROMs or USB drives, and thereby install a Linux operating system, doing very dodgy things. It's just basically looking for PCI sound cards. I'll tell it I'm not going to bother. And what it should then do is it should load up OPH crack. And what it's done is it's booted the Linux operating system and it's gone into Windows System32 config. It's found the hashed passwords. The hashed passwords. They're NT hashed. Notice Windows NT, because Windows 7 is based on Windows NT, so they're NT hashed. The hashes are reasonably complex, as you can see. It tries to do a very quick check, but at the moment the rainbow tables aren't loaded, so it's not going to find any of these. I don't have a password, but Bob, Emma, Joe and Anders do, so let's see if we can break those passwords. The first thing we need to do is load the tables. So we'll go into the tables and we'll install. The only ones that come on the live CD are the free ones for Vista, and they're very small tables, so they won't crack any really complicated passwords. But if you're willing to pay for them, they actually have rainbow crack tables that are huge, which will crack almost anything on a powerful enough computer. So I'm going to go into Media. That's a very good question. Which one of these do I want to go into? Probably HTC. Yep. HTC, Tables, Vista Free Table. I shall choose that. Okay, it knows it's on the disk now. And we'll say install. Oops, no, I've already done the install, so we'll just say OK. And we've now got the Vista Rainbow Tables installed. So what we can do is we can start the crack. It's already running, in fact. So there we go. And now it's just a matter of, let's see how quickly it can go off and it can find those passwords of those users. We've got user Bob, user Emma, user Joe, user Anders. The only one whose password I can remember off the top of my head is I made Bob's password in November. I think one of them was football, one of them was awesome, Anders was awesome, as Anders always is awesome, of course. And Emma's, I've completely forgotten what Emma's was. Okay, so that's running now, and this is a vulnerability in the older versions of Windows operating systems where they used to use these NT hashes, and they were exploitable by the OPH crack rainbow tables. So I would imagine that's been running for 1 minute and 7 seconds. What we'll do is we'll leave that running. It's already found awesome. Anders, yours was the first to go. I'm afraid your awesome password was not as awesome as it should have been. So it's broken Anders' password already. What we'll do is we'll leave that running whilst we have a little look at the rest of the slides. Well, some more of the slides. Okay, so the next thing we need to look at is what's known as the HAL, or the hardware abstraction layer. Now, because Windows computers use huge amount of different types of hardware, you imagine all the different models of computers, and there's also home-built DIY computers, all the different operating system motherboards, processors, network cards, video cards, Windows computers have to deal with a remarkable amount of different types of hardware, and yet the operating system itself can be installed on a computer straight off the shelf, or even if you build a computer from the ground up, which we actually did in the IT Essentials lecture earlier today. When the operating system is installed, it has to be isolated somehow or other from the differences in hardware. And the way this is done is we have what's known as a hardware abstraction layer, or HAL. And this is code that handles the communication between the hardware and the operating system kernel. The kernel is effectively the core of the operating system, so this has control over the entire computer. It handles all of the input and output requests, memory allocations, addresses, all of the peripherals connected to the computer, and this will communicate with the hardware through this hardware abstraction layer, which tries to present a sort of generic hardware to the kernel, even though you've got some very specific hardware in reality. Okay. Hasn't broke any more passwords yet. I'm just keeping a little eye on it out of the corner of my eye, so to speak. And we look at what's known as user mode and kernel mode. So two different modes in which the CPU operates when Windows is installed, and these are user mode and kernel mode. So installed applications would run in user mode, and the operating system code itself would run in kernel mode. Any code that's operating in executing in kernel mode will have unrestricted access to the underlying hardware. This makes sense, it's the operating system, and is capable of executing any CPU instruction. So kernel mode code can also reference any memory address directly. Okay, so these things are generally reserved for the most trusted functions of an operating system. Any crashes in code running in kernel mode could stop the operation of the entire computer. Programs, on the other hand, will run in what's known as user mode, and user mode has no direct access to hardware or memory locations. The user mode code has to go through the operating system in order to access hardware resources, so this provides a level of isolation. So crashes in user mode are restricted to the application only and are recoverable. So you've noticed this sometimes if you've ever had Microsoft Office crash. It doesn't normally take down the entire operating system. So most programs, in fact, in Windows will run in user mode. Now device drivers, on the other hand, these are pieces of software that allow the operating system and the device to communicate. These could run in either kernel mode or user mode depending on the type of driver. Okay, it's not correct any other passwords yet. I'm steadily looking at it. So Anders, your awesome password was unfortunately not so awesome. But it was a good one for test purposes because it cracked it pretty quickly. Okay, the Windows file system. So the file system actually organizes how information is stored on the storage media. And in certain situations, some file systems may be better choices than others, depending on the actual type of media that's in use. Typical file systems used by Windows are FAT, which is the file allocation table. It's a very simple file system. It has limitations on the number of partitions and the partition size and the file size that can be addressed. So FAT is no longer used really for hard drives. Hard drives are just far too big in capacity, or solid state drives. Back in the old days with smaller hard drives you might have found FAT16 or FAT32. FAT32 is quite common on things like USB sticks though. You have exFAT, and this is an extended version of the FAT operating system. It has fewer restrictions than the old FAT32. We have what's known as the hierarchical file system, HFS+. This is used on the Mac OS X computers. It allows much longer file names, file sizes and partition sizes. And though it's not actually supported by Windows without special software, Windows is able to read data from a HFS+ partition. Then we have what's known as ext. Ext is the extended file system. This is a file system used on Linux-based computers. Linux would normally use X3 or X4. Again, this is not supported by Windows, but Windows is able to read data from an ext partition if it has special software installed. And then we have the most useful file system for a Windows machine, which is NTFS, the New Technology File System. This is the most common file system now used when installing Windows. All versions of Windows, and indeed many versions of Linux, will support the NTFS file system. NTFS supports very, very large files and partitions. It's also very reliable, and it supports recovery features. It gives you more advanced security descriptors, so you can actually set the security up in NTFS in a much more granular level. Oh, it's just cracked another one. In fact, I'll show you, just because it's rather cool. So it has now cracked November. So Anders and Bob, you're no longer safe. We have your passwords. Now, to be fair, I think that the other two, well, football wasn't particularly hard, but I think the other one was reasonably tricky. On a real system, a fast system running natively, this cracks passwords much faster than it is doing on a virtual machine. But nevertheless, you can see it's actually working. Okay, so a hard drive is divided into areas called partitions, and each partition is a logical storage unit. And these can be formatted using one of these different types of file systems. FAT's probably FAT32 NTFS these days. In the case of Linux, X3, X4, RiserFS, such that data files and applications can actually store information, can be stored on there. Okay, the Windows boot process. Ah, my goodness me, yes. Okay, so there are a lot of things happen between the time that you press the power button and Windows is fully loaded. There are two types of computer firmware in wide use now. We have what's known as the Basic Input-Output System, or BIOS. This is the older version, and the more modern Unified Extended Firmware Interface, or UEFI. Now, the BIOS was actually created way back in the early 1980s, and it pretty much works today the same way it did then. Now, as computers have evolved, especially with the size of hard disk drives, it's become difficult for BIOS firmware to support all the new features. So the UEFI, or Unified Extended Firmware Interface, was designed to replace the BIOS. One of the nice things with the UEFI is it can support very, very large hard drives, and also the UEFI is generally a GUI, so you can even use a mouse inside the UEFI. Okay, so if we were to actually look at the process that actually happens after a valid, well, the BIOS initializes first of all, and then it will do what's known as a post, which is a power on self test. So it will check to make sure that all the components are working the way that they should. It will then go off and look for the master boot record, which is normally the first track on the hard drive, and it will look for what's known as bootmanager.exe. The bootmanager.exe file is then run, and it switches the system from what's known as real mode into protected mode, so that all of the system memory can be used. The bootmanager.exe will then read the boot configuration database, or BCD. The BCD contains any additional code that is required to start the computer, along with certain indications of whether the computer is coming out of hibernation or whether it's a cold start, etc. If the computer is coming out of hibernation, then the boot process will continue with what's known as winresume.exe. So this allows the computer to read the hiber file, sys file, which contains any state information about the computer regarding the state of the computer when it was put into hibernation. I've been talking an awful lot today. The mouth is stopping working properly. If the computer is being booted from a cold start, then what's known as winload.exe file is loaded. The winload.exe file creates a record of the hardware configuration that lives in the Windows registry. The registry is effectively a record of all the settings and options and hardware and software that the computer has. We do have in this chapter, and I recommend you have a little look at it, a really good lab on exploring the Windows registry. When winload.exe executes, it also uses what's known as KMS, or kernel mode code signing, to make sure that all of the drivers are digitally signed. So they're actually digitally signed by Microsoft to make sure that they've come from a trusted source and do not have any malware attached to them. Okay, so the drivers are safe to load as the computer starts. After the KMCS, the drivers have been examined, winload.exe will then run ntos kernel.exe, which actually starts the Windows kernel and sets up the hardware abstraction layer. And then finally, Session Manager subsystem reads the registry to create the proper user environment, starts the Win login service, and prepares each user's desktop as they log in. Wow. Yeah, there's a lot there, isn't there? I've still got passwords coming in by the looks of things. Have we got any more? No, no more yet. Okay. It was a good job we started that at the start, because I'm hoping we'll crack at least one more before the end of the session. Talking about the Windows registry, like I say, there's little point in me going over what's happening in the Windows registry because there's a lab for it, and I recommend that you do the lab. But the registry itself is a very dangerous place to be if you don't know what you're doing. If you change things inside the registry and you don't know what you're doing, you could actually cause some serious problems for the computer. There are a couple of important registry items that are actually used to automatically start applications and services. So what we've got is we've got these HKey local machine and HKey current user. Okay, so HKey local machine, there'll be several aspects of the Windows configuration that are stored under that key, including information about services that start with each boot up. And HKey current user, there are several aspects related to this about the logged in user, including information about services that start only when that user logs into the computer. Okay, so we've got 5 tabs. We've got the General tab, a Boot tab, a Services tab, a Startup tab, and a Tools tab. Time-wise, we've only got 15 minutes left. I probably would like to go a little bit further. We've got what are known as processes and threads. So a process is any program that is currently executing, whereas a thread is a part of that process. We can use the Task Manager in order to examine processes that are running on the system. Task Manager, very, very powerful, very useful application or utility, I suppose you could call it. Also, in the labs, they will tell you how to set up the sysinternals application. The sysinternals application is much more powerful. Memory allocation and handles. We're actually running sysinternals now, and there is a link in the relevant lab that will allow you to install this software. So we can see virtual address space, we can see 32-bit, we can see 64-bit. Each user address process runs in its own private address space. And what they're using here is they're using the sysinternal RAM map. It's incredible how much really high quality free software there is out there. We can actually see the registry there. You can get to the registry by typing regedit, but like I say, be very careful what you're doing in there. There's an interesting little lab in this chapter where they edit some entries in the registry, which basically cause the system to ask you again for the legal information, the licensing, when an application's been run for the first time. So I recommend you to look through these labs. We can run programs as the administrator quite simply by right-clicking on the program and going down to Run as Administrator. There are many reasons why we would need to do this, but they all revolve around the extra permissions that the administrator has. So for a security best practice, it's not advisable to log into a system as the administrator or on a Linux machine as root. Okay, because any program that is executed while logged in with those privileges will actually inherit those privileges. So malware, for instance, if malware actually runs while you're logged in under the administrative privileges, so the malware effectively inherits those privileges, it will have full access to the files and folders. So it's best to avoid being the administrator or the root user until you absolutely necessary. In which case, if it is necessary to run a program as the administrator, we can simply do a right click in Windows File Explorer and choose Run as Administrator. Okay. No more passwords cracked yet. Okay, we've got the situation with the local users and domains. So when you start a computer up for the first time or you install Windows, you'll be prompted to create a user account. So this is a local user account, and this account will contain all of your customized settings, access permissions, file locations, and other user specific data. There are two other accounts present though. There's the guest account and the administrator account. However, both of these are disabled by default. It is good security best practice not to enable the administrator account, and do not give standard users any administrative privileges. If a user needs to perform a function that requires administrative privileges, the system will ask for the administrator password and only allow that task to be performed by the proper administrator. Okay, so this protects the computer, preventing any software that's not authorized from being installed, executed, or accessing any files. Now, we also talk about a domain. Now, a domain is a type of network service where all of the users, the groups, the computers, the peripherals, and the security settings are actually stored on and controlled by a database. And that database, which in the case of Windows would be an Active Directory database, is stored on a special computer or group of computers known as domain controllers. Each user and computer on the domain has to authenticate against the domain controller in order to log in and access network resources. So the security settings for each user and computer are set by the domain controller for each session. Obviously, much more powerful way of doing centralized administration and security. Interesting thing, this computer that I'm using to do these recorded sessions is quite powerful. It's i7 Extreme processor, 6 cores, 12 cores with hyperthreading, 32 gig of RAM and two 500 gig SSD drives. So it's not a weak computer system. However, with that OPH crack running in that virtual machine, I can actually hear the fans ramped up to quite a high level, and my mouse movement has actually slowed down. When I'm clicking between these slides, they're actually coming up slower than they normally are. So I would imagine we've probably got some pretty serious processor utilization going on here. Let's open up a command prompt in Linux and just type htop and see what we've got going on. Yeah, there's a fair amount of processor utilization going on here. There's numerous cores hitting 100% utilization. In fact, it looks like there's pretty much 2 cores all the time hitting 100% utilization. That'll probably be 1 physical core and 1 virtual core, because the Intel hyperthreading. Yeah, and what's using all of that processor? We've got something going on down here. VirtualBox. Yeah. Okay, so it's ramping out a couple of cores, which is probably actually 1 actual core comprised of a physical core and a virtual core. Wow. Okay, in fact, if I just use top, htop is rather nice, but if I just use top, is that going to give me a little bit more information? Yeah, look, 201% processor utilization. Obviously, 201% means really it's running 100% on 2 full cores. Goodness me. Okay. Moving back to Windows. The CLI, Windows Command Line Interface, often called the DOS prompt, even though on modern versions of Windows we're not really using DOS, we're using an underlying NT system and a far more powerful PowerShell. These give you a a command line interface access to the operating system. So from the command line we can actually run programs, navigate the file system, manage files and folders. We can create batch files, for instance, to execute multiple commands in succession. In order to open the Windows CLI, we just can go to Start Run, type CMD, or search for cmd.exe and click on the program. We can right-click on the program in order to run CMD as an administrator. This gives us much more power for the commands that we're using. PowerShell is even more powerful command line access. PowerShell can also be used to create scripts and automate tasks. However, it can do things that the regular command line interface is unable to create. So PowerShell is an integrated program within Windows, and it can be opened by searching for PowerShell and then clicking on the program. There's numerous other ways you can do that as well. There are types of commands that PowerShell can execute. So we've got commandlets or CMDlets. These are commands that perform an action and return an output or an object to the next command that will be executed. We actually have PowerShell scripts. These are files that have the extension .ps1, and these contain actual PowerShell commands that can be executed in a script. And we have PowerShell functions, so these are pieces of code that can be referred to, be referenced in a script. We've got some good levels of help in Windows PowerShell, and we can literally type get help and then follow that with a PowerShell command, and that will give us basic help. We can type get help followed by a PowerShell command with hyphen examples, and this will give us basic help for the command with examples. We can put hyphen detailed for more detailed help, and hyphen full, which will give us all the help information for a command in even greater detail. So Windows PowerShell, again, there's a good lab. It's best to do that lab and work your way through it. We've got the Windows Management Instrumentation. This is used for managing remote computers. Quite a lot of attacks today will actually make use of, they'll leverage the WMI to connect to remote systems and modify the registry and run commands, so access to WMI should be strictly limited. And then of course we've got the net command, most famous probably use being net use, but there are many net commands that we can use. Again, there is a lab for that one, so time wise we've only got a few minutes left. I won't go over the lab for that one. We'll have a little look, see if there's any more passwords being cracked yet. There's only a few other little things that we could look at we do run into the server, but we've run out of time, I'm afraid. 1 hour, we can only cover so much in 1 hour. But like I say, there are an awful lot of very useful labs in this chapter, and I would definitely recommend doing those labs before you attempt to do the associated end of chapter test. Okay, so there's using PowerShell lab, there's a task manager lab, we've got a lab for monitoring and managing system resources, WMI. We've got the netstack command. Yeah, the netstack command works in Linux and in Windows. Though in Linux you would normally use on more modern versions the SS command instead. This will actually allow you to look at inbound and outbound connections. So we can look at listening sockets. Socket is a combination of an IP address and a port number. We can look at established connections. So it's very useful to run this command just to see what applications are actually network capable and listening on your computer for connections, and which established connections have been made. The event viewer, again, always very useful to look your way through the event viewer, particularly in the security tab and the system tab, to look at the logs. Always try to make sure that you have the highest level of protection against attacks. So make sure that your Windows is up to date with the latest service packs I should say, and security patches. Windows will routinely check the Windows Update website for any high priority updates. Don't forget there are such things as zero-day attacks, and a zero-day attack is gold dust for black hat actors, because the zero-day attack has no protection. The very first time a zero-day attack is used, there is by definition no protection against it, because nobody has seen it before. However, once it's been used once, then all of your security companies will be going full tilt in breaking that code up, working out exactly how it works, and producing defenses against it. So those defenses come around very quickly. However, you won't be able to take advantage of them unless you keep your Windows operating system up to date with the latest service packs and security patches, and your antivirus program up to date as well. Okay, I think we've just about run out of time. Yeah, we have really. Hey, it's got football. I was really hoping it would get that third one before we finished. So we've managed to get awesome football in November. The one it didn't get, which I'm just trying to remember what it was, it's back up here somewhere in the comments list. Where are we? Windows 7 VB was Carl's one. Well, that is a better example of a password. It's not a great one, admittedly, but it is a somewhat better example than the others. This piece of software, off crack, if we were running this on a native system, actually on the bare metal, it would run very, very much faster. It would have completed this probably in about 5 minutes instead of 30 minutes, or possibly even less. On a Windows XP machine, you can get the live disk for XP as well. I've actually cracked a 14-character password with lowercase, uppercase and numbers in 1 minute and 14 seconds on an XP machine. However, Windows, great work, they've done their job, and this will not work on a Windows 10 machine. Windows 10 is absolutely bulletproof against off-crack. Okay, I hope that was a useful session for you. I'm back at home in my more familiar environment next week. So next week we're on chapter 3 with the Linux operating system. I'm going to feel so much more warm and fuzzy when we've got a Linux operating system in front of us. So I hope you can join me next week for chapter 3, the Linux operating system. Same time, same place. And I'm just going to go and lay down in a nice quiet place for a little while and have a nice cold Guinness. Thank you very much indeed. See you next week.